All right, last section in chapter 1, scatter plots. Scatter plots are slightly different than graphs. It's a comparison of two things to see if there's a correlation that exists. So meaning that one thing is affecting another thing to change. So if you look over the years, what could you say about the cost of bread? Right, it's going up. Now, yeah, we had a little drop here, but you could generally say as time progresses, the cost of bread increases. Generally, keyword generally. It's not a linear relationship, so when you graph this, you'll notice that your points don't consistently go up in a consistent nice line. This is what makes this a scatter plot, because the number or the points are scattered. So what you want to do is you want to be able to look at this and make a prediction. So if in 2000 bread is already $1, then we know in 2010 it's going to be over $1, right? Because we can make a prediction based on our scatter plot. Yeah, we had a little droppage here, but for the most part, it seems like it's going up each year. So that would be our prediction on that. This is the number of months. By the way, there are three types of correlations. There's positive correlation, there's a negative correlation, and there's no correlation. All of these are represented in your math book. A positive correlation is when X is going up, causing Y to go up. A negative correlation is as X is increasing or changing, then it's causing Y to go down. That's a negative correlation. A no correlation is X is changing up, Y is not affected. That's a no correlation. So this is as the months progress, do the number of babies increase? Do the number of babies decrease? Or nothing at all? So if you look at that scatter plot, it's all over the board. So you're going to say that has no correlation. The height of a basketball player and the number of rebounds. Remember the key word that I'll say to you all the time is generally. Especially in a scatter plot, because it's not a consistent linear line. But you can generally say the taller the basketball player, so as the basketball player's height increases, the number of rebounds increase. Remember, if you have a double increase, that's a positive correlation. Let me show you what the writing is on that, because you'll have to write it. As the height increases, the number of rebounds increases. That makes it a positive relationship. Shoe size and test scores. What? No. As the shoe size increases, the test scores are not affected. No correlation. Outside temperature and heating bill. So always start your sentence off like this. As the outside temperature increases, what happens to the heating bill? I would think it would decrease, right? So negative correlation. Eye color and test scores. What? No. There's no relationship there. This shows Fahrenheit and Celsius. Is there a correlation? Yeah, because they're one and the same thing, but they're just in different types of units. One's United States and one's Canada. Definitely a correlation, definitely linear, definitely positive. I already said that. So make a prediction is, what they put there is called a best fit line. So if they wanted to predict if it was 35 degrees Celsius, you come to 35, you go up, you hit your best fit line, and you come over to say about 95. Wait, let me go back. About 95 degrees Fahrenheit. So this is hours spent studying and test scores. Is there a correlation? Well, I would hope so. I would hope that the more time you spend studying, the better your test score. I would hate to think it would actually go down. So there is a correlation. As the hours increase, your test scores increase. If I asked you to make a prediction after 7 hours, well, you better, 7 hours of studying, you better get close to 100%. If not, you don't know what you're doing. You better ask some better questions. Done. Done with chapter 1. Good luck.